Okay, so now we're going to do a little curve fitting. What we're going to do is we're going to do linear curve fitting. So our goal here is to write equations for lines that are going to be described. So let's take a look at this example here. It says to find an equation for the line with slope m equals 2/5. So the slope of this line is 2/5, rise over run, rise 2, run 5, that passes through the point -3, 4. And it also says to write the equation in standard form. All right. So let's go ahead and come up with an equation first. And there's a handy little tool we have for coming up with equations. It's this right here, point slope form. So this reads if a line passes, or sorry, if a line has slope m, we have the slope m, 2/5, and passes through point x1, y1. We also have a point. X1 would be -3, or y1 would be 4. So we have everything we need. The slope m, 2/5, and a point, x1, y1, -3 and 4 respectively. It goes on to say, then the point slope form of the line is given by this little nifty formula here. So let's go ahead and write the point slope form of this line. Based on what we just heard, the point slope form of the line is going to be y minus y1. Well, y1 is this number right here. Is the y value that comes from the point. Remember, that point is x1, y1, which implies that y1 is the number 4. So I get y minus 4 equals m. Well, we know that m is 2/5, 2 over 5. So m is 2/5. And then we're going to multiply m by x minus x1. x1 was this other coordinate here, -3. All right, we don't usually leave double negatives, minus a negative. We usually write those as plus. So this equation would become y minus 4 is equal to 2/5 multiplied by x plus 3. Now here's the thing. This little theorem here says that this is the point slope form of the line. What they want me to write the equation in standard form. So I need to have this in standard form. I already have the equation that I need. I just need to write this equation in standard form. Well, the standard form of a linear equation is ax plus by equals c. And in this form, a, b, and c should be written as integers, and a should be a positive number. So basically, we need to get rid of all fractions and make sure that a is positive. So let's go ahead. We already have the equation. This is the equation of the line. I just want to write the equation in standard form now. So that's what I'm going to be doing in green here. Well, starting with this equation, which is in point slope form, what I want to do to put it in standard form is first, I want to multiply both sides by the denominator of this fraction, which will allow me to get rid of the fraction. So I'm going to multiply the left side of the equation by 5, and I'm going to multiply the right side of the equation by 5. So what I had was I had y minus 4 equals 2/5 of x plus 3. And what I'm doing is I'm multiplying both sides of that equal sign by 5. What happens on the right-hand side is what's important. You see, on the right-hand side, the point of multiplying by 5 was to cancel this 5 with this 5. So I'll end up with this new equation here. I'll have the equation 5 times y minus 4 is equal to 2 times x plus 3. That step where I multiplied both sides by 5, the sole purpose of that step was to clear the fractions, to get rid of the 5 in the denominator of the right-hand side, and that's what it looks like when you get rid of the 5. Now I want to put it in this form. Notice in this form both variable terms are on the same side, the terms that have x and y as a factor, and the constant term is on the other side, and there are no parentheses. So first thing I'm going to do now is I'm going to get rid of the parentheses with distribution. I'll get 5y minus 20 on the left side equals 2x plus 6 on the left side. Now I need all the constant terms to be on one side and all the variable terms on the other. Since I want to keep the coefficient of x positive, I'm going to move the 5y over to the right side by subtracting 5y from both sides. subtract 5y. On this side, they'd cancel out, leaving me negative 20 is equal to 2x plus 6 minus 5y. And then the last step is to subtract 6 from both sides. Subtract 6. So I'll get negative 26 is equal to 2x. These would cancel, minus 5y. Now, because it's an equal sign, it doesn't matter which order we write each side on. So we could put 2x minus 5y equals negative 26, and it means the exact same thing. And here I have it in the form ax plus by equals c, where a is 2, b is negative 5, and c is negative 26. So here we've done the problem. We've written that line in the line that they described up here. We've written the equation of that line. We already had the equation at this step, but now we've put that equation in standard form. All right. Let's take a look at another example. This one says, find an equation for the line with slope m equals 0 that passes through the point negative 3, 4. Write the equation in standard form. So this one, it passes through the same point as the last one, right? But in this case, the slope is not 2/5, the slope is 0. Well, we've probably discussed in class already that the slope of a horizontal line is always 0. So just by virtue of the slope of this line being 0, I know automatically this is a horizontal line. All right? I'm going to use this form anyway. If a line has slope m and passes through point x1, y1, this is the point slope form. I'm going to use this to come up with the equation. If you have a little intuition, you'll remember that when a line is horizontal, all that you're really given in the equation is what y has to equal. So we should expect this to be the equation y equals 4. Let's see if it pans out. So we know that the equation of the line is going to be y minus y1. y1 in this case is 4. Equals m, which is 0, times x minus x1, and x1 once again is negative 3. So I get y minus 4 is equal to 0 times x plus 3. Well, regardless of what the value of x plus 3 is, regardless of what value you get there, when you multiply that number by 0, you get 0. So this equation turns into y minus 4 is equal to 0, because 0 multiplied by anything is 0. Once you have this, you can solve it for y to put it in the standard form, because we want to write the equation in standard form. Well, standard form is ax plus by equals c, which means all the variable terms have to be on one side and the constant term has to be on the other side. So what I'm going to do is I'm going to add 4 to both sides to make this y equals 4, and then you see that this is ax plus by equals c, where a is 0, y is 1, and c is 4. So here is the standard form of the equation of this horizontal line that goes through negative 3 comma 4. So that same equation works. All right, let's take a look at one last example here. All right, so for this example, it says find an equation for the line through negative 2, 5 and 3, negative 2. So I have 2 ordered pairs there. Write the equation in standard form is what it says. Same directions. Well, before we were using this, the point slope form of a line, to come up with the equation of the line in this form. And then we were putting that form in standard form. We were changing that to standard form. But in the case where we want to use this, we have to know the slope m. In this case, we're not given the slope m, but it's relatively easy to find the slope if you're given 2 points. This is the equation that'll do that for us. If a line passes through x1, y1 and x2, y2, then the slope of the line is m equals y2 minus y1 over x2 minus x1. So basically, this is x1, y1, this is x2, y2, and we're going to go ahead and find the slope. So x1 is equal to negative 2, y1 is equal to 5, x2 is equal to 3, and y2 is equal to negative 2. All right, so if we want to find the slope m, the slope is going to be y2, which is negative 2, minus y1, which is 5, divided by x2, which is 3, minus x1, which is negative 2. So negative 2 minus 5 is negative 7, and 3 minus negative 2 is positive 5. So here I have the slope. I just had to use this formula initially to find the slope, okay? Now, once you have the slope and you know a point that the line passes through, and we actually know 2 points, we have more points than we need, then you can use this formula, this theorem, to write the point slope form of the line. So here's the point slope form of the line. Y minus y1, we said y1 was 5, is equal to m, which we just found out was negative 7 over 5, times x minus x1, and x1 is negative 2. So we'll get this. Y minus 5 is equal to negative 7 over 5 times x plus 2. And to put this in standard form, we follow the same procedure. We want to clear the fraction, so we're going to multiply both sides of the equation by 5. So we multiply by 5 on this side and by 5 on this side. Let's see, this is y minus 5 equals negative 7/5 times x plus 2. Well, the point of doing that is that the 5's on the right-hand side will cancel out, leaving me the equation uh, 5 times y minus 5 is equal to negative 7 times x plus 2. Once again, we'll get rid of the parentheses with distribution, leaving me 5y minus 25 is equal to negative 7x minus 14. And what we want is we want all the variable terms to be on one side and the constant term to be on the other. So to get all the variable terms on the same side, I'm going to add 7x to both sides because I also want the coefficient of x to be positive. So I'll have 7x plus 5y. I have to write those side by side because they're not like terms. I can't combine them. Minus 25 is equal to, these two will cancel out, negative 14. And in the last step, I need to move that constant over to the other side. So I'll add 25 to both sides, and I will have 7x plus 5y is equal to, and this is going to be what, 11? 11. So here you have it. This is the standard form of that line that was described that passes through those 2 points. It's ax plus by equals c, where a is 7, b is 5, and c is 11. So that is the conclusion of our linear curve fitting video.